Hi, what's up? This is the optical trapping demo. So essentially what we do is we got a laser beam, and it's, laser beam qualities, it's collimated and all that good stuff. And we send it into a lens, and that lens focuses it down. A common thing about lenses is you focus it down and it's not actually perfect, it's not a tight focal point. And usually that's not a desired effect because you want things to be tight, but in this case, what you get is when the laser beam focuses down that focal point, there's a lot of constructive and deconstructive interference that happens in there, and that creates regions of high intensity from constructive interference and low intensity from deconstructive interference. And it's like little pockets of low intensity surrounded by high intensity. So in that focal point then, there's a lot of these little pockets, and what we have here is a slide of soot. We literally take a candle, which is over there, we burn it and just put this right over the edge of the candle, and soot just kind of harvests on here. It's nice and convenient, it doesn't fall off of this. And we slide the particle through, you'll see in a second, that trapping region. And what happens is, because of the photophoretic force, which is a thermal force, the particle is pulled off, or at least a couple particles are pulled off of the slide and they're held in place. And because of the photophoretic force and the fact that things in nature generally want to be in the lowest energy state, when the particle is pulled off, it likes to stay in the dark region surrounded by the hot region. So even if it gets kind of pushed out to the side, it goes back to the center. And then you'll see what that actually looks like.
Alright, so now let's try some work.
So there's a camera in there, and then there's also this. Who knows if either of those are going to show up. So that's the soot slide that's going through, and in a second, there you go. So if you close the top, you'll see it better. That's our trapped particle right there. You can see it's literally something that's being levitated in air only by light alone and these thermal forces, which is nice and cool. And then you can see that Jacob is going to kind of move the thing around pretty sporadically. You can kind of give it a good push. And that particle stays in place, and though it's kind of falling out, but so be it. This is because this force is continuing to push this back into that dark trapping region. And then the side effects of this is, now you have a particle in air, and it's nice. If you spin a laser real quick on a wall, it looks like a solid circle. Imagine you did that with this particle in the air, bada bang, bada boom, you get like a Star Wars hologram, which isn't a real hologram, but I'm not going to go into that. That's about it.